Okay, so 7.6 says the rational zero theorem. And the rational zero theorem says if p divided by q is a rational number in simplest form and is also a zero of the function y equals f of x, then p is a factor of the constant and q is a factor of the leading coefficient. So what we're going to do is we're going to come up with a list of possible places where my graph could cross the x-axis. So instead of using my calculator and looking at the graph, I'm going to come up with a list of possible ways or places that my graph can cross the x-axis based upon these p and q thing. Okay? So let's just practice coming up with the list of possible places where it could cross the x-axis. Alright, so it says p over q is a rational number, that just means a fraction, in simplest form, so reduced form, and it's a zero of the function, meaning it's a solution. The numerator is a factor of the constant, and the denominator is a factor of the leading coefficient. Okay, so let's look here at number 1. It says list all the possible rational zeros of each function. And then in A there it says f of x is 3x to the 4th minus x to the 3rd plus 4. Alright, so p. P is the constant. Which one's the constant? 4. And what are factors of 4? What are numbers that multiply to give you 4? 2, right? What else? 4 and 1. Alright, now, we don't know if this guy is a positive 4 or negative 4 or if, you know, all that sort of jazz. So we have the possibility that it could be positive or negative. So what I'm going to do is I'm going to put a positive or negative, and then I'm just going to list the factors of 4. Do I care about the order? No, I don't care what order you write them in. So if you wrote 2 and then 1 and 4, that's okay with me. Okay, well then the rational zeros told them that q is factors of the leading coefficient. Which one's my leading coefficient? 3, right? He's the guy in front of the one with the biggest exponent. Well, my biggest exponent is 4, so my leading coefficient is 3. And what are factors of 3? 3 and 1. And again, they could be positive or negative. So then my rational zero theorem says we're going to divide those guys. My factors of p are going to be my numerators. My factors of q are going to be my denominators. So all I'm going to do is I'm going to take all of my p's and divide it by each one of my q's. Plus or minus on all of them. 1 divided by 1 is still 1. 2 divided by 1 is still 2. 4 divided by 1 is still 4. However, I could take 1 and divide it by 3, or 2 and divide it by 3, or 4 and divide it by 3. Those are the only possible places for my graph to cross my x-axis. He won't cross anywhere else, as long as it's a rational number. Now, it could be irrational, but those are the only rational places it could cross. So it's not possible for that guy to cross at 8. Does that make sense? Like I said, he could cross at an irrational place, like 3 plus the square root of 7. That's an irrational place for it to cross. So when we go to do our synthetic, these are the only places it could be. So we're going to use this list in conjunction with our chart to find our roots. Okay? All right. You ready to try another one? Letter B here. P. P is my constant. Which one's my constant in letter B? 15. What are factors of 15? 15 and 1, right? 3 and 5. Like I said, I don't care about the order. How about Q? What's my leading coefficient? 1. It's a whole lot nicer when my leading coefficient is 1, right? Because what are the factors of 1? 1. Sweet. So my P divided by my Q is really just my list of P's because I'm going to divide them all by 1. 1, 3, 5, 15. My, like, OCD can't handle it when they're out of order. Good morning, Miss Sally.
Good morning. Do you have all the students accounted for? Do you have any visitors?
Anyone extra? There's no extras at the moment.
Can you believe it?
I'm not sure anybody would want to join this as an extra. She had a kid in Algebra 1 tell her that he was in my class and came to my class. I'm like, are you kidding me? I'd be so lost, right? Like, could you imagine doing this if you're supposed to be in Algebra 1? No. I think he's a little liar. You say it's a short lady with shortish hair. There's lots of those, right? Yeah. It's a pretty good cover. Okay, questions on that? Like I said, those are the only places that guy can cross. That guy won't cross any other place as a rational number besides plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. So it sort of narrows it down a little bit for us. Okay, so look at number 2. Ooh, number 2 is a good one. Number 2 says, find all the zeros of f of x equals x to the 5th, minus 2x to the 4th, minus 12x cubed, minus 12x squared, minus 13x minus 10. That's lots of minuses. So we're going to do the exact same thing we did last time, except for now we're going to come up with a list of numbers that they could possibly be. Okay? I'll also tell you a hint. In previous years, I've made them do this part without a calculator, right? So what did we do yesterday? We put it in our calculator and we graphed it and saw where it crossed the x-axis, right? Previously, I've made them do it without a calculator. Am I going to make you do it without a calculator? No. You're welcome. Happy birthday or something, because Christmas is over, right? So, that being said, we can still use our calculator a little bit, but I need to see all of your work. Does that make sense? Because we still have to depress our polynomial. So, it says find all the zeros. So we're going to still do all of the same things. We still have to do our chart. So how many roots am I looking for? 5, right? So let's go ahead and get our chart done. Okay, so if I count sign changes here, positive to negative, there's 1. Negative, no, 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 no. So there is only 1 positive root. Like I said, I won't make you find 4 imaginary roots anymore. So the next 4 won't be imaginary. So we've got to have some negative roots, right? Okay, so let's do f of negative x. Flip the signs of the odd exponents. So 5 is odd, so I'm going to flip him. 4 is even. I'm going to keep him. 3 is odd. I'm going to flip him. 2 is even. I'm going to keep him. 1 is odd. I'm going to flip him. Keep the constant. And now I'm going to count sign changes again. Negative to negative, nope. Negative to positive, there's 1. Positive to negative, there's 2. Negative to positive is 3. Positive to negative is 4. So 4. 4 minus 2 is 2. 2 minus 2 is 0. So I can have 1 positive, 4 negatives, and 0 imaginaries. 1 positive, 2 negatives, 2 imaginaries. 1 positive, no negatives, and 4 imaginaries. Hopefully it's not that bottom guy. Griffin.
So do we have 3 columns because we're doing something different, or is it because the 2 subtracts from the 0?
Because the 2 subtracts to the 0. Yes, good question. So we've got 3 rows because this guy keeps subtracting. Bless you. You're welcome. Okay, so that part we've done before, right? Now we're going to do our P's and our Q's. Ever heard your mom? Maybe not your mom. Your grandma? Remind your P's and Q's. It's because they were really math-oriented. They love math. That's why they said it to you. Yeah, didn't you know? This is what they were talking about, all of them. I guess I'll dream it. Okay, so my P's. What's my constant? 10, right? Negative 10, but we're just going to say 10. And remember, it can be a plus or a minus of all of that. So factors of 10. 10 and 1, 5 and 2, right? Q. 1. Okay, so my factors of 1 are 1. Sweet. So my P's over my Q's are plus or minus 1, 2, 5, or 10. Okay, now, let's look at our chart. I'm going to write them all out, right? That means we have negative 1, negative 2, negative 5, negative 10, right? Or positive 1, positive 2, positive 5, positive 10. Based upon our chart and our list, what do we know? We have 1 positive, right? Well, here's my list of positives, 1, 2, 5, and 10. It has to cross at one of those places. And only one, right? Once I find one that works, are any of the other ones going to work based upon my chart? No. How do I know it's going to work? We could cheat and look at our graph, but what else? What am I going to get in my remainder box? 0, right? So normally what I would say is, okay, go find it. You don't have your calculator, go find it. Will you do the synthetic, and if you don't get 0 in the remainder box, does that guy work? No. That's a lot of work, right? But we've got it. All right, here we go. We're going to depress our polynomial until we get down to an x squared. So we have to depress our polynomial how many times? 3, right? A lot. I like it. All right, here we go. 1, negative 2, negative 12, negative 12, negative 13, negative 10. So, either you've cheated, which is fine. What number shall we try first? 1, 2, 5, or 10? All right, JJ says try 1. Okay, I'm going to try 1. 1 times 1 is 1, negative 1. Negative 1 is negative 13. Negative 13, negative 25. Negative 25, negative 38. Is that guy going to work? No. Okay, so it's not 1. There's a reason they use pencil. Okay, what do you want to try now? We know one of these has to work. We're down to 3. 5?
Yes.
Okay. Blake says use 5. 1 times 5 is 5. 5 plus negative 2 is 3. 5 times 3 is 15. Add down. 3. 5 times 3 is 15. Add down is 3. 5 times 3 is 15. Add down is 2. 5 times 2 is 10. All right, we found one that worked. Are 2 or 10 going to work? No. Cross them off. We don't want to try them anymore. Our chart tells us there's only one positive rational root. So there's no point in trying any more of them. Now we got to depress our polynomial 2 more times though, so I need to put some negatives in there. So what do you want to try as a negative? Why it says -2? At least I think that's what you said, why? Okay. I gotta get a 0 in my remainder box or he's not a solution. -2 times 1 is -2, add down is +1. -2 times 1 is -2, add down is +1. -2 times 1 is -2, add down is 1. -2 times 1, hey, it works. All right, so we've got 2 so far. That means at least one more of them will work. Based upon our chart, if we have one -1 that worked, another one has to work. Now what do you want to try? -1. Okay. I gotta get 0 in my remainder box or he doesn't work. Oops, that's a positive. -1 times a -1 is a -1. Add down is 0. -1 times 0 is 0. Add down is 1. -1 times 1 is -1. Hey, it worked. So far, how many roots have I found? 3. I have 5, -2, and -1. I really like it when that guy right there in the middle is a 0. Makes my life nice and easy, right? Because this guy is now 1x squared plus 0x plus 1. Or x squared plus 1 equals 0. And if I don't have a linear term, I don't have to do the quadratic formula, and I don't have to complete the square. I can just solve that guy. So move the 1 over. Take the square root. I took the square root, so I get a plus or a minus. Square root of -1 is plus or minus I. Okay, so what are our solutions?
-2, 5, -1, plus or minus 5.
Awesome. -2, -1, 5, plus or minus I. Whoa. Sorry, you can't see that. What do you think? Jillian. How do we know what? Say it again.
How do we know you
We could keep going if we wanted to. Oh, sorry. We could keep going with the synthetic, but we don't know. So we knew it wasn't that big, right? We don't know if any more of those will work. So we could keep doing the synthetic all the way down. But if they're not rational numbers, none of the other ones will work. Does that make sense? We didn't. But once you get down to 3, then we can complete the square, use the quadratic formula, that sort of thing, so that in case they're irrational or in case they're imaginary, those ones will show up. Does that make sense? So we do it enough to get 3 numbers in front of the remainder box, so that in case those numbers are irrational or imaginary, or even if they are rational, we'll still find those ones. Okay, would you like to do one more together? So there's number 3 here. That's an x to the 4th. And then there's a number 4 on the back, and he's an x to the 4th as well. Should we do one of those more together? Let's do one more together, and then I'll give you lots of time to work. Any preference? What do you think? Why it wants 4? Is that okay? Okay. 4 has more going on.
More room to do work.
More room to do work. I like it. Okay, so it says find all of them. Alrighty, here we go. I'm going to start with my chart. How many roots are we looking for? 4. My degree is 4, so I'm looking for 4 roots. Alright, sign changes. Positive to positive. Nope. Positive to negative, there's 1. Negative to positive, there's 2. Positive to positive, nope. So I've got 2. 2 minus 2 is 0. Alright, I'm looking for my negatives. So p of negative x, flip the signs of your odd exponent. So I have x to the 4th, minus now x cubed, minus 19x squared, minus 11x, constant stays, plus 30. Okay, sign changes. Positive to a negative, there's 1. Negative to negative, nope. Negative to negative, nope. Negative to positive, there's 2. Gotta add to 4 going across. So there's either 4 imaginaries or no imaginaries. Okay, P's and Q's. P's your constant, so which one's your constant? 30. Okay, factors of 30. 1 and 30, 2 and 15, 6 and 5,
3 and 10.
3 and 10. Any other ones? No, I think that's good. Q. Factors of your leading coefficient. What's your leading coefficient? It's sure nice when it's 1, right? So the only possible places are at 1, plus or minus 1, 2, 3, 5, 6, 10, 15, and 30. All right. I would suggest we either start with positives or we start with negatives. Okay? So, it's totally up to you what we start to try. But now we're going to go to our synthetic. 1, 1, negative 19, positive 11, 30. Again, make sure you have a pencil with an eraser, because we got to get a 0 in the remainder box. What do you want to try?
1.
Okay. 1 times 1 is 1, add down is 2. 1 times 2 is 2, add down negative 17. Negative 17 times 1 is negative 17. Add down is negative 6. Is that going to work? No. Okay, 1 didn't work. Two, okay. One plus 2 is 3. 2 times 3 is 6. Add down is negative 13. 13 times 2 is negative 26. Add down is negative 15. Oh, hey, that one works. Negative 30. Sweet, we've got 1.
Is the only way to come is really just bring us in?
Yes, essentially. Technically, David, you still have your calculator. So, I mean, yeah, you could look at it. But I also need to see your work. Does that make sense? So it's not like you can go ahead and list all the solutions off for me. Okay, Griffin, what do you think? 3. Okay, Griffin says try 3. Bring it down. 1 times 3 is 3. Add down is 6. 6 times 3 is 18. Add down is 5. 5 times 3 is 15. Sweet. So now I have 1x squared plus 6x plus 5. Now, me, personally, you have 2 options. You can try to see if this guy factors. And if you're good at factoring, go for it. If not, I would say go to completing the square. Okay? Does this guy factor? Mm-hmm. Yeah, he certainly does. I have a plus and a plus. So what are 2 numbers that multiply to 5 that add to 6? 5 and 1. So x plus 5 equals 0. Sorry. X plus 1 equals 0. So x equals negative 5. X equals negative 1. Notice those guys are also on our list. Okay, how do you feel? You feel better about the synthetic and the solving and finding all the roots? Better than yesterday, right? Jillian.
So if we wanted to make it a bit faster, is it okay if I wanted to make it faster?
Yeah. That's perfectly fine. So Jillian just said, is it okay if I put it in my calculator to make it faster so I'm not spending a whole bunch of time guessing and checking? You bet. If you want to put it in your calculator and say, hey, I'm going to look for those 2 positive roots, then do your 2 positive ones. That's perfectly fine with me. If, like on this one, you're like, hey, I know I've got 1 positive root, so I'm going to put it in my calculator, find that 1 positive root to save myself some time. I'm okay with that. Okay? You still have to do the synthetic because we have to depress our polynomial. Okay? Okay, so let's look at your worksheet. So, it feels like a lot, but on 1 through 6, all you're doing is listing your P's and your Q's, and P's over Q's. So those ones should go fast. So 1, 2, 3, 4, 5, 6, these guys are just the P's, Q's, and P's over Q's only. Then starting at 7. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's a lot. Right? How about pick a column. Does that feel better?
Yeah.
That gives you time to finish 7-5, if you need to finish 7-5, and then pick one column, either odds or evens. So you're doing 1, 2, 3, 4, you're doing 5. Does that sound good? Jillian?
Is it odd and even for the first part, or is it-
No, do all of the top ones, and then odds or evens starting at 7. Sound good?
Yeah.
That feel better? Okay. I just want to make sure you've got enough time to work, and I'm here to help you. So starting at 7, odds or evens. Okay?